This is recording 1C in our series on quadratic functions in vertex form for Unit 3, Chapter 3 of Mathematics 2200. We'll be combining the transformations we learned about in recordings 1A and 1B to look at the graph of a function in vertex form, y equals a outside of x minus p squared plus q. Quick bit of review from those first two recordings. Y equals ax squared, vertex is 0, 0, and the a value stretches the graph to make it wider or narrower. Y equals x squared plus q has vertex 0, q, and translates the graph up or down depending on the value of q. Y equals x minus p squared, the vertex is at p and 0, translates the graph by p units left or right. And the value of p, it's important to remember when the number is bracketed in here with the x, the value of p is the opposite sign of what you actually see. So let's put all the transformations together. Let's take a look at this first example. Y equals 2 outside of x minus 3 squared. I'm going to graph it and compare it to the base graph. Notice how I've put a 3 in the middle of the table? That's because the 3 minus the 3 will give me a 0 in here. So that's likely going to give me the vertex. Let's see if that happens. Well, it does indeedy. 3 minus 3 is 0, squared is 0, times 2 is 0. So we do get that 0. Still not quite sure about the vertex part. Well, it looks like the points are beginning to mirror here when I put in 2 for the x and 4 for the x. I get the same y values. Let's complete the rest of the table. Well, it does look like the points are mirrored on either side of x equals 3. Let's plot the graph. So I've plotted my points and I've traced out my base graph. Moving it to the right 3 units is not enough to make that graph fit those points. I have to do something extra. Remember, multiplying by 2 right here has the effect of stretching the graph to make it wider or narrower. If it's a bigger number, bigger than 1, it makes it narrower. So let's stretch it to make it narrower. There we go. Way up there. And somewhere up there it passes through 6 and 18 and 0, 18. So the vertex is now at 3, 0. We have a vertical stretch by a factor of 2, which happens to be the same as the a value. A equals 2, so we're stretched vertically by a factor of 2. The vertex is at 3, 0. Well, our p value, remember, is 3. So our vertex should be at 3, 0. We don't have a q value other than 0. So we don't have any vertical translation. The axis of symmetry, you'll notice, is at x equals 3. X equals the p value. Now this time, let's take the exact same example except for one small change. We do have an a equal 2, so the vertical stretch should still be 2. The p will equal 3, but now the q value is negative 4. Remember, the q value keeps the sign of the number that's there. Like the previous one, I put 3 in for my x value to begin in the middle of the table because that's where my vertex is going to be based on my p value. That's what I always like to put in there in the middle. So when we calculate, we've got negative 4 right here. If I put in my values on either side of x equals 3, let's see what happens. 4 minus 3 is 1, squared is 1, times 2 is 2, subtract 4 is negative 2. Likewise, on the other side, 2 outside of 2 minus 3 squared, that's negative 1, times 2 is 2, subtract 4 is negative 2 again. So it looks like 3, negative 4 should be my vertex, the P and Q value. So having plotted the points, I need to take the base graph, translate it 3 units right, which is my P value, and 4 units down, which is my Q value, to get it to meet the vertex that I've plotted. However, I need to stretch the graph as well, just like in the last example. So we have translations 3 right, 4 down. We have a vertical stretch by a factor of 2, because that's our A value as before. The axis of symmetry is x equals 4, that's x equals our P value, and we'll notice that in both this example and the previous one, the graph still opens up. For this last example, notice that we've got an x plus 3 in here, so that means our P value is negative 3. Our Q value keeps its sign, so Q equals 4. The A value is negative 2. Let's see what effect that has on the graph. I've started my table again with my P value in the middle, and I calculate there. So I've completed the table and much of the information here, plotted the points, and I've traced out my base graph. First thing I'm going to need to do with the base graph is to reflect it. Then I'm going to need to translate it 3 units left and 4 units up to meet the vertex. Then finally I'm going to have to stretch it by a factor of 2. So to summarize, we have a reflection across the x-axis, translations are left 3, 4 up, and a vertical stretch of 2. To conclude, our vertex is located at PQ, axis of symmetry is x equals P. The value of A affects the direction of opening. If it's positive, it opens up, negative opens down. Also affects the width, and the values of P and Q are translations.